Welcome back, dear students. So we are discussing laws of motion. Okay, in laws of motion already the three parts completed. So in the part one we discussed Newton's laws. Okay, afterwards in part two we discussed about the connected bodies. Okay, afterwards in part three, last part we discussed lift cases. Okay, so the apparent weight of a man in lift. Okay, and string cases also we discussed. And today we are going to discuss about the laws of motion part 4. In this part 4 we'll discuss about the main topic, friction topic. Okay, the friction questions continuously they are asking in entrances like JE and Neet and Eamcet also. Other competitive state competitive exams also they are asking. Okay, so here friction cases, if we understand the concept easily, we can solve the frictional problems. Okay, the friction related problems easily we can solve. Okay, so by knowing the cases concept, how the formulas, how we can solve. So now today we'll discuss in this class. Okay, let's start. What is friction? The friction means what? Okay, so the frictional force means what? So for example, so when the body is resting on horizontal surface, okay, so that time what happens, the weight of the body acts vertically downward. Okay, the weight is balanced by another force that is vertically upward. That force is called what? Normal reaction, denoted by symbol what? N. Normal reaction denoted by symbol what? N. So here this body at rest, that meaning is what? The weight of the body, okay, and this normal reaction both are balanced. So that is why the body is in equilibrium. Okay, so if you apply little bit amount of force, what happen? So body may not move, means against some force is acting. Okay, so the against force, the opposing force only called frictional force. Okay, for example, so one body is in uniform motion. Okay, after some time what happened, body comes to rest. The body comes to rest. Why? What is the reason? So some opposing force is acting on that body, so that is why the body comes to rest. Okay, so generally, so we'll observe, for example, one smooth surface is there. Okay, so we'll think that is a very smooth surface. Okay, but whenever seen, okay, from under powerful microscopes, so what happens, so this surface consists of elevations and depressions. Surface consists elevation depressions. Okay, so when the body is moving on, okay, that surface what happens, so the body also consists some elevations and depressions like irregularities. So when the body is, okay, interlocked between these, okay, elevations and depressions, like so interlock like this system, what happen, body does not move. Okay, so this is called, okay, frictional force. Okay, frictional force means nothing but opposing force between the two bodies in contact. Okay, so in the horizontal surface purpose we can observe, okay, the weight of the body is acting vertically downward and normal reaction is acting vertically upward. Okay, the normal reaction means what? So it is the contact to force between the, okay, so body and surface, and this normal reaction is perpendicular to the surface. Okay, perpendicular to the surface always. So it is perpendicular to the plane of the surface. If you take inclined plane also, so that is perpendicular to the plane. Horizontal plane also perpendicular to the plane. Okay, so first of all we'll discuss the about the horizontal surface. Okay, normal reaction. So what is normal reaction? Normal reaction, okay, so denoted by symbol what? N. Normal reaction is denoted by symbol N. Okay, so it is the, okay, perpendicular force between the body and the surface. It is always the perpendicular to the plane of the surface. Okay, and here normal reaction and weight of the body down. Okay, so W acts vertically, so equal and opposite directions. Okay, If you take the inclined plane, so inclined plane, what happened? The normal reaction, what we discussed, always perpendicular to the plane n only, okay, upward, but weight of the body is downward mg. Here, like normal reaction and weight both are balanced in this case, n equal to mg, but here not balanced, not equal, n and mg are not equal, okay. So here n is balanced by mg cos theta. How mg cos theta? This mg is resolved into two rectangular components, one is mg cos theta, another one is mg sin theta. So that is why this normal reaction is balanced by what? N equal to mg cos theta for inclined plane. Here theta is what? Inclination angle, okay. So on that inclined plane, so the normal reaction is balanced by mg cos theta. So detailedly we'll discuss later about the inclined planes, rough inclined plane, smooth inclined planes, okay. So what will be the normal okay, balanced by mg cos theta and resultant forces, that all we'll discuss later. Just now about normal reaction, try to understand the normal reaction, okay. Here in horizontal surface, that is balanced by mg, and inclined plane purpose any, okay, balanced by mg cos theta. So here friction definition we understood, okay. So here how many types are there? Frictions, okay. Types of frictions, how many types are there? Okay, help of diagram, so we'll discuss the, okay, types of frictions, okay. Observe here one horizontal table is there, okay. So in this horizontal table, so one block, okay, so one block of mass m, one block of mass m, so is placed on the, okay, table. So now this block is connected to a thread, okay. So the thread is passing over one frictionless pulley, okay, so like one wheel, okay, and the other end of the thread is connected to one weighing pan, okay. So we can add the loads in this weighing pan, okay. So here now observe here, just now we discussed what? The weight of the body on the horizontal surface acts vertically downward, that is mg, and normal reaction is perpendicular to the plane of, okay, so that is what? N, that is vertically upward, okay. So now what happens here when, okay, here load is very less, for example, so little amount of load is attached, so what happened that time? So the applied force, this load is nothing but, okay, applied force is less, what happened? Body does not move, body does not move. Why? So here against some force is acting, against some force is acting, okay. So that is called static friction. Body does not move at rest, at stationary, that is why we'll call that type of friction is called what? Static friction. Static friction time, so if we are applying some force but body is not moving, body at rest only, so that type of friction is called what? Static friction. The first types of friction, first, okay, static friction. Static friction, static friction is nothing but self adjusting force, okay, body at rest only. So why? Because our whatever we applied force, that is not enough to body move, okay. So that is why the body at rest only, so that is static friction. Now what I am doing, so more little bit amount of load is attached, so what happened now? Now also body is not moving, but body is tends to move, means ready to move. So whenever I added another load, what happened that time? Body is applied force is increased, body is ready to move, tends to move. So that time what happened? So the applying force against force is called limiting force, okay, limiting friction. The limiting friction is nothing but static friction only, body is not moving but body tends to move, so that is why this is called what? So this is under, okay, limiting friction comes under static friction only, but limiting friction means the maximum static frictional force, okay, the maximum static frictional force. So here static friction, if we denote with symbol Fs, the limiting friction we have to denote with symbol Fl, okay. Limiting friction means what? The maximum static frictional force, The maximum static frictional force. Okay, so friction also nothing but static friction, body at rest only, but body tends to move. Okay, if you add just 1 gram, okay, 1 gram of load if you attach, what happens that time? So the body moves. Okay, but we are not adding, body at rest only. So that time the maximum static frictional force is called what? Limiting friction. So next what I am doing, more load I am adding, more load I'm adding, what happens that time? Body slides on the surface, body slides on the surface, like so the interlocking system, and the body is moving, body is in motion. So that time what happens that time? That type of friction is called, okay, so what we'll say, dynamic friction or kinetic friction. So dynamic friction or kinetic friction means body slides on the surface, body sliding on the surface. So the type of friction is called what? Dynamic friction, dynamic or kinetic friction. Okay, here denoted by symbol Fk, or sliding friction also we can say. Okay, so compared to the static friction, this is the less friction. Okay, frictional force is less. Why? Because to adjust the motion purpose we have to apply more force. Once body is set in motion, so what happens that time? Easily we can drag. Okay, so that is why the static friction is more than kinetic friction. Okay, so here the another type is what? Another type is there, so that is rolling friction. Rolling friction means instead of this block, so arrange one roller, so like, okay, cylindrical shape or circular shape, okay, or sphere, so like that, any roller. Okay, so add, so what happened that time? So for little amount of force, okay, little amount of load purpose, body rolls on the surface. So that time against frictional force is called what? The rolling friction. The third type is what? Rolling friction. Third type is what? Rolling friction, denoted by symbol what? Fr. The rolling friction, okay, denoted by the symbol is what? Fr. Okay, so this rolling friction is very less compared to the kinetic friction and static friction. Okay, so the rolling friction is very less. Okay, the relation we can take, so Fr, the rolling friction is very less compared to the kinetic friction, compared to, okay, static friction or limiting friction, so this is very less. Okay, the rolling friction is very less. Okay, so here the kinetic and static friction, so does not depends on the area of contact. Kinetic and, okay, static friction does not depends on the area of contact, so just that depends on the nature of the body contact surfaces. The body and contact surface depends on, so it does not depends on the area of the contact, but the rolling friction, so depends on the area of contact, depends on area of contact. Okay, how? So this, okay, rolling friction is inversely proportional to the radius. If radius is less, what happens that time? So the friction force is more. The radius is more, what happens that time? For rolling friction purpose, so the frictional force is less, inversely proportional. Okay, so here the friction, static frictional force, okay, so always directly proportional to the, okay, static frictional force is what? Directly proportional to the, static frictional force is directly proportional to the normal reaction. Okay, so here Fs is directly proportional to N, means proportionality symbol cancel in time. What I am doing, some constant I am taking, so the constant is what? Mu s. The constant is what? Mu s. Okay, where mu s is called coefficient of static friction. Here mu s is what? Coefficient of static friction. Coefficient of static friction. Okay, so this coefficient of static friction, so mu s equal to, what is the letter? Mu s. Mu s equal to what? Fs by N. So here coefficient of static friction we can define as the ratio of static frictional force to the normal reaction. Static frictional force to the normal reaction. This coefficient of static friction does not consist any units or dimensions. Why? Because it is a pure ratio. So does not that is why. So it not consists any units or dimensional formulas. So that is the coefficient of static friction. So like that only another three also we can take, another two also we can take same thing. So for example, this is what, so this is about static frictional force we discussed. So next, for example, kinetic friction. Kinetic friction also directly proportional to the normal reaction, and kinetic frictional force is equal to what happens, mu k into n. So where mu k is called what? Coefficient of kinetic friction. Mu k is what? Coefficient of kinetic friction. And this kinetic friction F mu k equal to what? So Fk by n. Fk by n. The same formulas for three types of frictions, same three coefficient of frictions. So one is coefficient of static friction, another one is coefficient of kinetic friction. The kinetic friction, coefficient of kinetic friction is what? The ratio of the kinetic frictional force to the normal. So this one also, this kinetic coefficient of friction also does not consist any units and dimensions. And the last one is what? Rolling friction. The rolling frictional force is directly proportional to the normal reaction, and the rolling frictional force Fr is equal to mu r into n, and coefficient of rolling friction mu r is equal to what? Mu r is equal to what? Fr by n. Mu r equal to what? Fr by n. So here this one also we can define same, the ratio of rolling frictional force to the normal reaction. So this one also pure ratio, that is why it does not consist any units and dimensions. So these are the three types of frictions and their three types of coefficient of frictions. So here the relation is same only. So like that the coefficient of rolling friction is less compared to the coefficient of kinetic friction, and coefficient of kinetic friction is lesser than coefficient of static friction or limiting friction. So these are the three types of frictions, and their three coefficients. So the three are not consist any units and dimensions. So here advantages are what? We are discussing friction. So once if you imagine, if there is no friction, so what happens? So we can't walk on the floors, we can slip, there is no friction. So we can't hold anything, so like pen or drinking water glass, so we can't hold the slip. So here advantages are there for friction. So what are the advantages? Advantages of friction. So observe here advantages. Here safe walking is possible on the floor. Safe walking is possible on the floor because of friction between so floor and our feet. And the friction helps to hold the things like pen or drinking water glass. So like this, to hold the things purpose, the friction helps. For example, if you are so hand is oily, so we can't write properly with holding pen, we can't hold the pen properly first of all. The friction is required. So next, here the screws and nails are driven into the walls because of friction only, so otherwise they come outside. So the vehicles are moving on the road. So whenever we are applying brakes, so the time body comes to rest, vehicle comes to rest because of friction between the tires and road. If friction is not there, after using some years, the vehicle tires what happen, become flat. If you apply force, so there is no friction. What happened that time? So body can't stop exact position, so it stopped at certain distance, otherwise, okay, so for skidding also chances. Okay, so like this friction help. Okay, advantages are there for friction. At the same time, some disadvantages also there. What are the disadvantages? Okay, so you'll observe, so in the power, large amount of power is lost in the machinery parts. Okay, so what happened that time? The efficiency, okay, of machinery parts decreases because of friction. And okay, so some heat is released. Okay, so while machinery parts between the engine parts, so what happened that time? So the parts become heated, so that heat goes as waste only, and wear and tear of machinery parts increases. Okay, so due to that reason, what happens? The life of the machinery parts decreases. Okay, so you'll observe, so like for example ceiling fan, so it is rotating, so sometimes, okay, so their bearings are, okay, efficiency of bearings decreased or reduced. What happens? Some sound will be produces. Okay, so that time, what happened that time? So sound producing means what? The two parts of the bodies are rubbing, so the time what happened? Heat released, that heat goes as waste only. Okay, and the efficiency, while like the rubbing time, efficiency also what? Decreases. Okay, so these are the disadvantages are there. Okay, so how to reduce the friction? Okay, the two parts, machinery parts are rubbing, so what happened that time? The efficiency of the machinery parts decreases. So to avoid that one, to reduce the friction, so what kind of, okay, so process we have to take? So we'll see now. To reduce the friction, there are four methods are there. So in that first one is what? Methods to reduce the friction. Okay, to reduce the friction, so there are four methods are there. The first one is polishing. First method is there, polishing. The second method is there, okay, lubricants. Using lubricants we can reduce the friction. Third one is there, ball bearings. And fourth one is there, streamlining. So like there are four methods are there, we'll discuss, okay, about that four methods. The first method is what? First method is polishing. So by polishing the surfaces, so what happened that time? So like irregularities are filled by the polish. So like for example, surface is uneven, irregular. So whenever polishing time, what happened that time? That irregularities are, okay, irregularities are what happened that time? So become smooth. Okay, irregularities are become smooth. So that time friction will be reduced. Okay, friction is reduced. So that is one method. By polishing surfaces we can reduce the surfaces. Here one thing you have to remember, if over polish also, what happen that time? Friction increases. Okay, over polishing time friction increases. Okay, you have to remember that. And the next one, lubricants. Just now we discussed about the machinery parts. So there are two parts of the machinery parts rubbing time. What happened that time? The heat is generating, and efficiency of machinery parts also decreases. Okay, to avoid that, we have to apply the lubricants between the parts. Lubricants applying time, what happened? So the lubricants means nothing but the thin layer of oil or grease. Okay, so applying between the parts, what happened that time? So the parts reduce, between the parts friction will be reduces and smoothly runs. Okay, the machinery parts smoothly runs. Okay, in daily life also we'll observe so many examples are there. Okay, so what happens generally? The gates, okay, so the while closing time it is very hard, it is moving. What happened that time? So if you pour some oil or apply grease, what happened? It, okay, so becomes free. Okay, free can, it can rotate freely. So these are the, okay, general examples in the daily life. Okay, so like ball bearings, the ball bearings, okay, so we know that the two-wheeler, bicycle, motors. Okay, so they consist the wheels consist the ball bearings, like ceiling fan also consists the ball bearings. Okay, so these ball bearings consist the hard steel balls. Okay, consist hard steel balls, so they'll turn, okay, from sliding friction to rolling friction. So just now we observed, okay, the sliding friction is nothing but kinetic friction, so that force, okay, compared to that one, rolling friction is less. So that is why, so your friction can reduce. Generally we'll observe, okay, so luggage bags also are providing, okay, wheels. So that time what happened that time, so easily we can drag from one place to another place. Okay, so here sliding time, what happened, if wheels are not there, sliding time it is very difficult. The gas cylinder also we are observing. Okay, so just dragging time the full cylinder, so it is very difficult. If, okay, on roller if you keep that gas cylinder and you bring, okay, so very easily it can move. So why? Because here the rolling friction is less compared to the sliding friction. Okay, so next one, last one, streamlining. The streamlining means what? Here automobiles and aeroplanes are specially streamlined. Okay, the curved surfaces, they consist the curved surfaces. Okay, so nowadays we are observing the motor vehicles also, cars also, we are observing specially they'll design so that all, so to avoid the air friction, to avoid air friction purpose only they'll design the vehicles like that. Okay, so to reduce the air friction, okay, the streamlining is, okay, useful. So these are the four methods to reduce the friction. Okay, so first one is what? Polishing. Second one, okay, lubricants. Third one, ball bearings. And fourth one, streamlining. Okay, so now we'll discuss about the, okay, motion of the bodies on rough surfaces. We can observe here, okay, in this diagram, the horizontal surface, on the horizontal surface one block is resting, so the time the weight of the body is acting vertically downward, that is mg. Normal reaction is acting vertically upward, that is n. Okay, so these, okay, frictional force, you are applying some force but body is not moving, applying some force f but body is not moving. So why? Because the against frictional force is there. Okay, so that time what I am doing, the resultant of this normal and frictional force I am taking, okay, resultant force fr I am taking. Okay, the resultant of which one, normal and frictional force, is called resultant of, okay, frictional force. Okay, observe here the angle between normal and this resultant, I am taking the symbol phi. So that phi is called what? Angle of, okay, so angle of friction. The angle is called what? Angle of friction, denoted by symbol phi. The angle of friction is denoted by symbol what? Phi. So the angle of friction is, okay, so we can define like that, the angle between the resultant of, okay, normal and frictional force with normal, angle between this normal and, so to resultant, which resultant? Resultant of normal and frictional force, that angle is called what? Angle of friction, denoted by symbol what? Phi. So from here, okay, this is OA. Okay, this OA parallel. Okay, so we can take BC, we can take here, later I am taking C. OA parallel line BC. The OA is what? Frictional force. FL means this one also what? Frictional force, static frictional force or limiting frictional force. FL I am taking. Okay, and okay, this adjacent, okay, this one is what? Normal reaction N, normal reaction N. So that time tan phi, so from angle of friction, okay, so from the triangle OBC, so it is very clear, tan theta equal to what? Tan function, tan theta equal to what? Opposite side by, okay, FL or static friction force we are taking, FS also you can take, FS by, okay, adjacent is what? Normal. Tan function says opposite side by, okay, adjacent side, okay, Fs by n. Tan theta equal to Fs by n. Just now we discussed Fs by n, that is nothing but what? Static frictional force. Okay, static frictional coefficient of static friction. Okay, how? So from what we take in the time, Fs equal to mu s into n we taken. Okay, so here mu s equal to what? Fs by n. Mu s equal to what? Fs by n. So instead of f, okay, instead of Fs by n, we can take mu s. We can take mu s. Tan theta equal to, we can take mu s. Okay, coefficient of static friction we can take. Okay, so here theta r5 angle of friction we can take. Okay, so phi also we can take. The resultant fr is equal to, we can take under root, okay, the frictional force whole square plus normal whole square. Okay, resultant of friction, so under root fs whole square plus n square we can take. Okay, based on these cases, okay, so now we'll solve some problems, so then later, so we'll discuss in the next part, especially inclined planes, smooth inclined plane and rough inclined plane, all types of numericals and cases we'll observe in the next part of the video. Okay, in this part I'll explain the numericals about this. Okay, angle of friction and resultant force and frictional force, kinetic, okay, rolling and, okay, so static frictional force numericals we'll see. Okay, so first question you check on screen. A wooden block of 100 kilograms is about to be pushed on floor of coefficient of friction 0.4. What is the magnitude of the force of friction on the wooden block when it is just pushed? So here which case this one? So here one block is there. Okay, the block of mass is given. How much given block of mass is? Okay, so just 100 kilograms is given. 100 kilograms given. And here between the block and the surface, the coefficient of friction also given. The coefficient of friction mu value how much given? Okay, so 0.4 given. Okay, so here what happened the time to overcome, okay, the force, how much force should apply? Okay, so they are asking to push the body, just to push purpose, how much force is required. Here coefficient of friction also given, block of mass also given. Okay, so we know that the frictional force, okay, to overcome the frictional force, so what is the formula? From frictional force formula is what? So mu n. So here static friction means Fs equal to mu s n will take, kinetic friction means Fk equal to mu k n will take. So here this is the horizontal surface. Horizontal surface means just now we discussed n equal to what? Mg. N equal to what? Mg. So instead of n, I am substituting what? Mg I am substituting. Okay, mass into acceleration due to gravity. Substitute the values. F equal to mu value given, how much given? 0.4, and m value given how much? 100, and g value given how much? 9.8. So here observe these two decimal purpose, two zeros we can cancel. So 98 4 ja how much? So 8 4 ja 32, 3. Okay, so 4 9 ja 36. Okay, 3 39. 392 force units are what? Newtons. So therefore how much? Answer 392 newtons. Which option is correct? First option is correct. Next question you can check on screen. A block is in limiting equilibrium on a rough horizontal surface if the net contact force is root 3 times the normal force. The coefficient of friction is. In this case, what they are saying? Okay, so the resultant force, how much they are saying? Okay, so the net resultant force is root 3 times of the normal reaction. Okay, so we can take in this formula. Okay, so the resultant force Fr is given. How much given? Fr resultant force is given how much? Root 3 times the net force they given. Root 3 times the net force. Resultant force is root 3 times the net force given. Okay, so then they are asking coefficient of friction mu value how much they are asking. Okay, so we'll take that formula, resultant force formula. In that you substitute, okay, from, okay, resultant force Fr is equal to, what is the formula? So the frictional force Fs whole square plus n square. Okay, so here substitute the values. Fr is given how much given? Root 3 times the normal reaction. root 3 times the normal reaction. Okay, so here under root Fs square plus n square, here squaring on both the sides, what happened, root 3 whole square is 3, here n square. Why? Because so n root is not there, only root is for 3, so 3 n square is equal to, here square root get cancelled, Fs square plus n square. Okay, so that n square bring this side, what happened, 3n square minus n square is 2n square. Okay, Fs square equal to what, 3n square minus n square, that equal to 2n square. Okay, so your frictional force formula, just now we discussed what is the formula. So mu s, okay, n, mu s n whole square, so that equal to 2n square. Mu s n whole square means, shall I substitute individually? So mu s square n square is equal to what, 2n square. Here n square cancel, so mu s square equal to 2, mu s equal to what, root 2, mu s equal to what, root 2. So therefore coefficient of friction is how much, root 2, no units. So which option is correct here? First option only correct. Next problem you can check on screen. A block of mass 20 kilograms is pushed with a horizontal of 90 newtons. If the coefficient of static friction and kinetic frictions are 0.4 and 0.3, the frictional force acting on the block is, here what they are saying, a block of mass is given how much, 20 kilograms given, block of mass is given 20 kilograms. The applied force is given how many newtons, 90 newtons given. Applied same time two coefficient of static frictions are given. Okay, static friction and kinetic frictions are given, so 0.4 and 0.3 given. Okay, so they are asking what the question, the frictional force acting on the block. Okay, so frictional force acting on the block they are asking. So first we will find the static frictional force. We will find static frictional force formula is what, Fs equal to mu s into n. Here n is what, this is a horizontal body, okay, horizontal surface, so that is why n equal to mg I am taking. Fs equal to mu s into mg I am taking. So Fs equal to what, mu s is what, 0.4, body of mass 20 kilogram, g value 9.8. Here, okay, so decimal and 0 gets cancelled, 4 to the 8, okay, 4 to the 8. In this problem, okay, so the g value they only given how much given, 10 given, so 4 to the 8 into 10, 80 newtons. So we can observe here, it is very clear, our applied force is more than this frictional force, means, so this is what, body is sliding. Sliding means what to take here, kinetic friction we have to take. Okay, so from static friction, so what we concluded, this static frictional force is compared to this one, the applied force is, okay, applied force is 90 newtons means more, so that is why, so static frictional force is less, so applied force is more, so that is why this is kinetic friction. So that is why now kinetic friction you have to find out. Fk equal to mu k n, so here this is a horizontal surface, that is why, so n equal to what I am taking, mg I am taking. Okay, so Fk equal to what, mu value how much given for kinetic friction, mu k how much given, 0.3. okay, m is how much, 20 kilograms, into g value 10 they only given. Here decimal and 0 gets cancelled, 3 to the 6, 6 into 10, 60 newtons. So here the answer is what, okay, 60 newtons. Third option is correct. Okay, here you can observe second option 80 also given, but 80 is the wrong answer. So why? So here it is very clear, the frictional force is, okay, less compared to our applied force. So that time what happens, body slides means that is kinetic friction or dynamic friction. So that is why again we have to calculate the kinetic friction, okay, using formula mu k n, n is what, mg. Okay, so m into g, Okay, m is 20, g is 10, mu k they only given 0.3. Okay, so multiply this, 3 to the 6, 6 into 10, 60 newtons. Third option is correct. Okay, so like this questions they'll ask. Okay, basic questions these are. Okay, so next part 2 of friction. The next part, the most important cases are there, like pulling, pushing cases, and other inclined plane. Okay, rough inclined plane and smooth inclined plane cases. So the last question. Okay, so when the body is sliding down on rough inclined plane, so time taken is so and so. At the same inclination angle on smooth inclined plane, body is sliding down, so what will be the time? Okay, otherwise, okay, on rough inclined plane only for sliding down purpose, so and so time taken, and to slide up purpose, how much time it will take. Okay, another cases are there. Okay, the inclined plane, half of the part is rough inclined plane, another half of the part is smooth inclined plane. So for releasing a body from top to reach the bottom purpose, what will be the time, or what will be the velocity, or how much distance? Okay, velocity. Okay, so these are all questions. Okay, so we'll discuss in the next class. Okay, so don't miss that class, most important class, that one. Okay, and this way of, okay, this explanation, if you understand, okay, so please like this video and share to your friends. Okay, and don't forget to subscribe. Okay, thank you very much.